Welcome to this BeeGraphy tutorial, where we'll be demonstrating the power of computational design on the cloud by creating a complex tower structure with just a few simple nodes. Let's get started. The video demonstrates how to create a 3D tower model, which starts with two circles as its base. We then divide these circles into points and create an offset in the arrangement of these points, allowing us to draw lines between them to form the tower's lattice structure. First, we'll define a range of values that will control various aspects of our tower. Let's add a range input node. We'll set the minimum height to 40, the maximum to 80, and rename it height. Now let's create a construct point node to establish a point in space. This point will define the height and serve as the center for our circles. Connect the height range input to the z input of the construct point node. This lifts our point off the grid along the z-axis. Next, we'll generate two circles. Let's add our first circle node and connect the construct point to its origin input. To control the radius of the circles, let's create range input nodes. Set its minimum to 15, maximum to 35, and a step of 1 and rename radius 1. Connect radius 1 to the radius input of the circle node. Call the second range input radius 2. Connect radius 2 to the radius of the second circle node. Next, we'll divide both circles into a set number of points. Add two divide by count nodes. Connect the curve output of each circle node to the corresponding curve input of the divide by count nodes. To control the number of divisions, add a range input node with a minimum of 15, maximum of 25, and a step of 1. Named count. Connect the count node to the count input of both divide by count nodes. We need to change the order of the points. For this, we will use the shift list node. Add two shift list nodes. Connect the points output of each divide by count node to the corresponding list input of the shift list nodes. We'll adjust the order of arrangement using the range input node. Add a range input node, set its minimum to 0, maximum to 10, and a step of 1, named shift 1. Duplicate the shift 1 node, rename it to shift 2, and connect it to the factor input of the second shift list node. Connect shift 1 to the factor input of the first shift list node. The factor of the shift list node changes the order of the points. Now, let's connect the points on both circles with lines to form a framework. Add two line nodes. Connect the list output of the first shift list node to the point 1 input of both line nodes. Then, connect the list output of the second shift list to the point 2 input of both line nodes. This creates the crisscross pattern. To add more detail, we'll divide each line segment. Add two more divide by count nodes and connect their curve inputs to the line outputs. Create range input node, set its minimum to 10, maximum to 20, and named count. The count node, connect it to the count inputs of these new divide by count nodes. We connect the points of divide by count to the flip tree node. Flip tree node changes the direction of points. Now we'll create smooth curves that pass through these new points. Add interpolate nodes. We hide the points to make the resulting image more understandable. Finally, to give these curves a thickness and create our tower structure, add a pipe node. Create a range input node, set its min value to 0.2, max to 0.5 and a step of 0.1 and rename it radius. Connect this to the radius input of the pipe node. Connect the curve output of the two line nodes to the base curve input of the pipe node. Connect the curve output of the interpolate nodes to the base curve input of the pipe node. It's time to add some visual flair. Add Apply Material node. Connect the surface output of the pipe node to the geometry input of the first Apply Material node. Now let's transform the interpolated curves into surfaces. Add curve to surface nodes. Connect the surface output of the curve to surface node to the second Apply Material node. You can select any color you like to create a visually appealing design. Now let's activate the demo from the menu to the right and see our tower in action. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.